Hello friends, welcome to UGC PG Pathshala. I am Dr. Lubna Siddiqui, Assistant Professor, Department of Geography, Jamia Millia Islamia, New Delhi. Today I will talk about the module Technique of Model Construction in Geographical Studies, which comes under the paper Quantitative Techniques in Geography. Now, introduction. Model building and generalization of geographical facts are important and significant issues which have been increasingly addressing with the use of deductive explanation in the geographical studies. As geography deals with the spatial distribution of geographical phenomena, the construction of model is primarily concerned with three dimensions of geographical elements called 3Ds, that is density, distance and division. The detailed elaboration of these elements in geographical context is given below. Number A, the density. The density of geographical phenomena, which refers to the size area ratio, the amount and intensity of an attribute varies across area over time. In order to analyze and interpret the spatial dimensions of such attribute, a variety of techniques are used. The concept that forms the domain of geography is integrally associated with two. Number one, the physical geography, which includes many branches like geomorphology, climatology, biogeography and oceanography on one hand, and number two, the human geography that deals with the social, economic, demographic and locational aspects of the landscape of human activities according to Singh 2013. The technique of a spatial analysis of geographical phenomena is mainly focused on either phenomenal relationship or areal variation of the attributes based on its density. It leads to a conclusion how areas, regions are tightly bound up to each other geographically. Now B, the distance, that is networking and cost involvement. Analysis of location of a point or area becomes too important to make it more elaborative in its physical, that is natural resource base, and socioeconomic, that is functional base of location of an attribute context nowadays, when agglomeration dispersion economies are location based and dominate the activities in a region. It means that the ordering of a space, that is a spatial interaction, and organization of human activities, that is location specific for establishing economic as well as social activities, are primarily distance dependent. Distance involves the closeness of producers and users in market activities, which is viewed in three ways. Physical distance in terms of money involved a geographical element of spatial organization of economic activities. Distance in terms of time, when distance between places is considered as development of network connectivity, and thirdly, the cultural distance, when socio-cultural activities are more closely based on common language, modes of communication, similar customs and social norms. Now C, the division. We are not indicating here the political division as country boundaries, but we are more concerned with the spatial organization of geographic entities and planning within a political unit, that is country. A space does not have plane surface. Division of a space is required to study features on account of a spatial variation of economic activities. The geographical interpretation of attributes or variables follows its areal or regional characteristics. It involves a technique of division of a space, that is physical or socio-economic. Physical divisions of the whole, that is geographic space, and or classification of areal units to make spatial distribution of activities based on similarities within or dissimilarities between the areas involves the policy decision in regional planning. Thus, division of a space involves the policy implications. Further, division of a space is a technique which leads us towards logical classification called regionalization. Now, model building. It includes first, model building is a procedure for the development of a system. The followers of modern route of scientific research find generalization of facts proceeding through imposing the hypothesis and its validity testing either by using already built model or by constructing a new model considering the scientific route, that is development of proposition, imposition of conditions, use of axioms and assumptions, and later on calibration and validation of model to reach closer to the real world situation. Therefore, model building involves a specific procedure and steps as given in detail in the next part of present discussion. Construction of a model for the solution of a research problem is to search a quantitative procedure of selected variables required for obtaining the problem situation in its significant manner. Number 2, model is a toolbox. Since a research problem is multi-dimensional phenomena, it is tackled with a variety of tools to transfer unordered facts into ordered one to make generalization. Model thus works as toolbox. If we have modern tools and techniques, our model building is more scientific and such newly built models work better to search realities. In the book Models in Geography, authored by Corley and Haggard, they clearly state that models are reflection of reality of an object. We must keep in mind that tools which fit the purpose to infer realities are to be used in model building, otherwise we should not expect the correct results. For example, the statistical models are tested always with their significant test. If a quantitative model does not fit in reality, we must replace it and use another form of the model. For instance, suppose a linear equation for establishing relationship between the trend of y subject to x variables, that is y is equal to a plus bx, does not explain the fact significantly as we use standard error term to explain variation in the distribution. The non-linear equation as polynomial function may be used. If we compare the results of these two functions, linear and non-linear, and wish to opt one out of these two, we will have to keep in mind the error term. A smaller value of error gives greater degree of reality shown through the model. So, the choice of model for generalizing facts is largely dependent on error term to understand the significance of reality. As a result, model provides a strong base to reach closest to reality objectively. Third, models are used to systematize raw data set. A given set of unordered facts in the form of quantitative data collected from the research field cannot provide the general information until it is converted into a scale through which it can be attributed for inferences. Model is the tool through which unsystematic data is systematized. For example, suppose we have rice yield and rainfall data of few situations of an area. If it is depicted by a scatter diagram, the regression tendency of yield y subject to rainfall x may not be in a linear trend model. Following linear trend model, it is supposed to be the distribution is linear. The computed values of yield yc are used instead of observed one y0 because these values are considered more systematic than unless we know the error term of the model used for the purpose. Now, aspects of model building. One must be careful at the time of construction of model when model are made for a specific purpose. It, that is model construction, requires quantified variables, controlled variables with relaxed ones, that is dependent, independent variables, aggregated view of variables, time concept also be treated if required. Tools and techniques used, relevant data available, and inferences of main traits for generalization and development of laws. Such steps of the procedure of model construction are discussed below in detail. Step 1. Purpose behind model building. As per the research problems and issues taken up for solution, we have to determine the purpose of model building to prepare an alternative strategy for the solution and to provide deductive explanation. Step 2. Quantification of variables. Since one has to deal with the research problem in quantitative manner, the field work and data collection of objects are major tasks to frame research design. Imposition of hypothesis and prove it are dimensions which compel us for selection of attributes and variables. Variables are to be in quantitative manner in the tabulated form for further operation. Scaling of selected variables is primary task for model builders to look into the problems. Step 3. Controls on variables. When model builder is going to analyze the system, causality is main principle, keeping in mind that the answer of our research problem will be given logically. Cause-effect relationship is to establish by classifying variables into two categories, namely the effect variables, that is dependent or base, and cause variables, that is independent or factor. Say for example, crop yield is controlled by rainfall. We wish to establish relationship between crop yield and rainfall. Crop yield is dependent variable on rainfall, which is independent. Step 4. Time concept. Geographical studies follow space-time concept. One must include time as factor if required in the model construction. For example, if the development of model is towards the analysis of spatial development of socio-economy of a region, a set of 4 processes of development, barriers, hierarchy, network, and contiguity considered as elements of a space are taken into account with their different stages of time as shown in figure 1. Sometimes we do not consider time dimension if our study is based on one time scale and our data collection schedule do not include time dimension. The dimension of a space in model building is used in a variety of ways. A modern quantitative way of understanding a spatial pattern of an attribute has many steps like preparation of a map of the surveyed area and showing location data of activities collected from samples called spatial data. Such spatial data are depicted into geometric manner into zone system, and particular zone is notated by number or algebraic symbols as shown in figure 2. Figure 1 shows a spatio-temporal view of the development of economic landscape, whereas figure 2 shows generation of spatial data collected from the study area and its depiction into geometric manner, wherein A shows real map of the part of Delhi, B shows its geometric grids, and C shows algebraic notation by letters. Developing a good notation mathematically, a map area is to show in coordinates following GIS for accurate and speedy calculation and depiction of spatial features of variables. Such type of data depiction of objects given on map into its geometric form provides a sound base to reach closer to reality. The data generated into a coordinate form can easily be used for the purpose through GIS tool. Step 5. Techniques used for establishing cause-effect relationship. Choice of technique is based on the following three dimensions of its uses. Number A, assumption. It focuses direct attention towards the objective of research. When one constructs the model, some interrelated statements related to research problem are to assume based on speculation. Number B, conditions. That prepares a scale of the variability of variance. If we know the extreme conditions of variables, it must help in speculation of relationship between variables. Number C, axioms. That are well-established facts which are used sometimes, somewhere for establishing new relationships of facts. Now D, relationship prevalent in the system. Relationship between two sets of variables acts as integral part of the system that we wish to develop. After assembling the parts, that is tools of the system, and knowing their relationships, we reach to a point from where we may obtain the output of a model. If we are able to study the system which has parts and their assemblage, we are called mechanic who knows about the system. But knowing simply about the other part of the system, it indicates the operator of the system called driver. Model builder is a good mechanic. Now E, calibration and validation. It is the step which is useful for simulation, that is prediction of events which we need to analyze. Before it, validity testing of a model is needed. As per the use of model situation, there is a variety of deviation-based validity testing methods to use the significance level of model error. What is deviation-based testing? Model's deviation from observed data is based on its error term. For example, a linear model which establishes relationship between y, that is dependent, and x, that is independent variables, has error term as y0 is equal to a plus bx plus e and yc is equal to a plus bx. So e is equal to y0 minus yc, where y0 is equal to observed and yc is equal to computed values of a variable y. It is expressed by substituting yc function in y0 equation. The error of a model is tested in many ways. Statistical testing of a model is particularly based on two types of variations, that is the explained variation, which is expressed by degree of determinants R2, and secondly the unexplained variations, that is expressed in its degree of significance measured by the student's t-test. However, for different purpose, the ratio of the sum of a squared deviation with mean sum is used. Now step 6, simulation. When model is tested and ready to use, we can simulate the results of as event on the basis of generalization, that is the outcome of the model. Speculation of event and development of law based on generalization are major achievements of model building. Note that this procedure of testing validity is imposed hypothesis through the use of model, and explanation of real-world situation is primarily dependent on deductive explanation. Now fourth example, modeling retail sales in Delhi urban area, which includes number 1, research problem and its articulation. Retail sale is a major urban activity which contributes subsequently the city's economy. It is distributed ubiquitously and is found in each locality. Suppose our problem is intended to build the shopping centers in future, to choose the localities where location of new centers may be proposed. We will have to consider solving this problem, the cash flow from the locality, that is from population resides and creates sale demand, to the destination of locality where shopping, store, mall that is supply center, is located. Such problem of uneven distribution of population and shopping centers has these two economic variables, that is demand and supply of goods of retail sale. The third variable is distance between the locality where demand is created and location of shopping center, that is a variable associated with attractiveness force. An associated variability is cash flow from one locality to another one, that is showing intensity of sale, which is dependent on these above cited variables. Expenditure on shopping in each locality may be used as converter of total population into its sale term in each locality. Now, we are interested to know the spatial pattern of cash expenditure on consumer goods in each locality and its flow to the locality where shopping center is located. In this process of articulation of problem of measuring the total demand and supply of consumer goods and its spatial pattern, sales of each locality is dependent on cash flow from one locality to the others. As we are more concerned with the spatial data of retail sale, the actual map of locality boundary, which is a tool for showing sale pattern, is generalized zone wise instead of locality wise to make it more general and operative with GIS to generate data of distance. This modification may be made by using either longitudinal and latitudinal system on which GIS is based or coordinate, that is XY system. Zones are named locality wise or signing geometrically number as name I is equal to 1, 2, 3 and n. Note that I refers to a particular zone of residence and J is zone of shopping center with the condition I is equal to J as shown in figure 3. Size of zone and its total numbers are to be determined by the planner as per the size of whole study area or spatial resolution at which we wish to develop the spatial pattern of sale of consumer goods. Distance between a set of two zones, that is Dij, may now be measured by using vector or raster system to apply Pythagoras theorem for the point coordinates expressed as Dij is equal to xi minus xj whole square plus yi minus yj whole square raised to the power half. Taking account of above cited and considering the steps as described in the preceding part of the present discussion, we can now consider the generation of variable and their relationships. When we know that I represent the zone of the origin of flow of money and J for the zone of destination of flow, the flow of money pattern is from I to J. Second is assumptions. The sale of consumer goods in a particular zone J is the function of intensity of flow of money expressed as Sij, and flow of money from one zone to another is function of distance Dig. A few assumptions generalized on distance cost relationship and on shopping goods are used here as: number 1, distance Dig Dij is considered linear between ith and jth zone. Number 2, travel cost, that is Cij, are linear function of distance. It means Dij is proportional to Cij. Number 3, there is some amount consumers of a particular zone keep safety in their pockets, that is Aij. They do not spend total money on sale which they have to reach to jth sector. It is also included in travel cost between one zone to another to buy goods and material. Thus, distance variable is included in the form of its travel cost and expressed as shown in figure 3. Dij is equal to Aij plus Cij. This is the equation 2. Figure 3 shows quantitative concept of distance. Now, 3 conditions. There are 3 conditions of cash flow from I to J zones. Number 1, the cash flow from I to J is proportional to alpha, the total money available for shipping expenditure in I zone, which is dependent on the household's income, EJ. Indirectly, sale in shops located in J zone are proportional to per capita income into total population, PI, in J zone. So, Sij alpha EI PI, this is the equation 3. Number 2, the cash flow that is indicative of intensity of spatial interaction through sale intensity from I to J is also proportional to the size of sale center Mj in J zone, that is factor of attractiveness be expressed as Sij alpha Mj, this is equation 4. Number 3, the cash flow that is means sale intensity from I to J zone diminishes as travel distance increases. It means it is proportional to distance, but inversely as Sij alpha 1 upon Dij, and this is equation 5. Now 4, model and its testing. Under these assumptions and conditions of sale in shops located in I zone and using proportionality constant, that is x proportional to y, may be written as x is equal to ky, where k is constant. The relationship of above conditions may be expressed as Sij is equal to k into Ei Pj into Mj into Dij, as shown in equation 6. If we observe now that the emerging form of relationship between the amount of sale among population size of shopping center and distance, it follows Newton's gravity model in physics, which also has a constant and interaction between two masses as Fij is equal to k mi m2 upon d12 raised to the power 12, and this is equation 7, where alpha, beta and n are coefficients in relation to population size, sale size and distance. A linear form of the above constructed model is log Sij is equal to log k plus alpha into log Ei Pj plus beta into log mi minus n into log Cij, and this is the equation 9. It is obvious to say that the sale of consumer goods in a zone, that is locality, increases logarithmically since coefficients operate in power function as population as well as shopping center sizes increase, and it decreases as distance increases. It is log into log distribution of attributes. There has been a deviation of observed figures of sale in each zone Sij 0 from predicted one Sijp, which is calculated through the equation 8. The simplest measure of such deviation is the sum of squares as used here with double summation sign as E is equal to summation I minus 1 n summation j is equal to 1 n into Sij O minus Sijp whole square, and this is the equation 10, where E is equal to error term. If E is 0, there is no deviation. Such variation may be tested by using any significant test as described somewhere else in the module entitled Basic Sampling and Test of Significance for Large Samples. Now, fifth is model utility. There are 3 main dimensions to use this model of detail gradation as given below. A, since the model predicts the sale of consumer goods in each zone and generalizes spatial pattern It can be used as logical deductive explanation of sale pattern to understand the areas of fast supply zones to expand sale counters or shops in the city. Now B, the future requirement of shopping centers is demand based, increasing population and increasing per capita income in I zone EIPI, increased demand of sale counters or centers if model is calibrated by changing its coefficients and constants as per the increasing demand of zones. The retail sale amount as well as location of shopping centers may be simulated to develop its new spatial pattern future. Therefore, it would be useful for development of infrastructure in the city to make proper city planning. Now C, the total sale at jth zone for whole area is summation Sij is equal to S1j plus S2j plus S3j plus Snj. This is the equation 11. The prediction of such sale of the area can be used as benchmark for infrastructural planning of a city. Now summary. There are two approaches of writing a report on research issues or problems. The pattern approach, when data of attributes are collected, processed and classified to understand the facts, and second is the system approach through which we wish to understand the process and the working of the internal assemblages of the parts of a system and to know about its output. Model building is the main aspect of the second approach through which a deductive explanation and generalization of facts is proceeded by using hypotheses, hunches or assumptions or specific conditions and so on. Such explanation leads us towards construction of law and theories. I hope you have understood the concept of technique of model construction in geographical studies. See you next time. Thank you.